The broadcast is now starting. All attendees are in listen-only mode.
All right, welcome everybody. We'll give a couple more minutes as people still keep coming in. We get started in just a couple minutes. You may notice that you don't have a microphone. If you want to ask questions, there's a question box in the GoToWebinar control panel. You can put a question in there, and then I will either answer it verbally or possibly write the answer. Maybe I can get somebody just to test it out, just write test or something like that, and we'll see what it looks like. Hopefully you're hearing me. Maybe somebody can put a question in the question box just to test it out. All right. Got no takers. Okay.
We do have a couple of test options in the questions box. I'm not sure if you see that, Miles.
No, I'm not seeing anything in the questions box. Wonder if it's. Wonder why I'm not seeing anything in my question box. Is that Lee?
Yes.
So you can see the questions in the questions box, but I can't. It's very strange. Are there options of who to ask the question of? It might be just going to the organizer.
Okay, well, if we have any questions, I'll be happy to moderate and we can answer them during the duration of the presentation.
Okay, thanks a lot.
No problem.
All right, we got that solved. Well, let's jump right in. My name is Miles Brown, and I'm an AWS instructor and also Google Cloud authorized trainer. And the idea of the workshop today is just to compare the public cloud providers, from 2020, so up to date. Mostly we'll be looking at the big three providers, which is Amazon Web Services, Microsoft Azure, and Google Cloud. But we'll just talk about some of the other players in the market. And here's what the agenda looks like. We should be here for about an hour. I think probably my material is around 45 minutes or so, and then we'll have 10, 15 minutes for questions. But we'll start with the models of cloud services, just really putting some terminology around things. And then we'll get into the overview of the various public cloud providers. A little bit more terminology there, but just get you an idea of what they do. And then really get into the comparison of them. And kind of look at what's the sweet spot that each one does well, sort of the case for each. And then we'll talk a little bit about the idea of going multi-cloud, which is becoming more and more popular these days. And we'll end the session with a question period, and we'll figure out how to do it by then. So the models of cloud services, you probably heard these terms, maybe not. Infrastructure as a service, platform as a service, software as a service. These are some terminology that people use. And it really comes down to what are we putting on the responsibility of the cloud provider, and what are we taking on as the responsibility as a customer, right? So if you think In my own on-prem data centers, I'm kind of in charge of everything, starting from getting the networking and buying servers and putting them in racks and everything, right? But when you go to a cloud provider, basically what you're doing is you're saying, I don't want to be in the data center business. I want to rent virtual machines from somebody, by the hour or by the minute or whatever their billing is. But I don't want to have to think about hardware, right? I'm going to get basically an operating system, and I'm in charge of that operating system up, everything I install on it and all that. And so that's the idea of infrastructure as a service. It just says, don't worry your pretty little head about dealing with all these physical machines. We'll let Amazon or Microsoft or Google do that. Okay? And so that means that there's still a lot of administrative burden on your part. You still have to have, people who either know how to administrate Linux or Windows or whatever. The next level up is where you say, why don't I allow the cloud vendor to do even more? And that's what we call platform as a service, or sometimes you'll hear people call it PaaS, the PaaS. And that's where you say, well, what if they took care of more? Like say I was running a relational database and I didn't want to have to manage the operating system and the file system and install the database and then patch the operating system, patch the database, set up nightly backups. The most mundane DBA tasks I could let the cloud vendor do. Now that's a big trade-off, right? What if they don't do the administration the way I want them to? Well, then maybe I might not want it, right? And then the highest level is software as a service, right? Now, the public cloud providers really focus on the infrastructure and the platform as a service, but they do have some SaaS offerings. And if you think about things like Microsoft Office 365, G Suite, Google's productivity tools, things like Dropbox, Salesforce.com, basically I don't have any infrastructure that I manage at all. I just go and kind of configure how their software works and I use it. And it's all hosted and run and managed for me. And so there's lots of SaaS offerings out there for all kinds of things. But when people talk about public cloud, they're usually either talking about infrastructure as a service or platform as a service. That's normally what we're talking about. And so some examples of PaaS include, well, I just mentioned that concept of a relational database. AWS has RDS, the relational database service. And so they have about 6 different database engines that you can choose from. And basically you say, hey, I want to run an Oracle database, but I don't want to be a DBA. I'm going to let a brainless algorithm at Amazon be my DBA. Now that's quite a trade-off, but I'm no longer the DBA. All I get is a JDBC or an ODBC driver, and I connect to it, and I'm a user of that database. But I don't see the virtual machine. I can't remote into it. I don't get to touch the operating system, but then I also don't have to worry about it. Right? If you look at Azure and Google Cloud, they have very similar things. Another example of a PaaS offering that's really nice is the Azure App Service. And so if you're using Microsoft Azure and you build .NET web applications or something like that, they make it really, really easy to take that zipped up application. As a developer, I go and I build some .NET app and I say, okay, here's my zip file. And you take it and they say, oh, okay, we're going to put it into a nice elastic infrastructure so that, when all of a sudden my web app gets busy, they'll add more virtual machines to handle the load, and then they'll get rid of them when we're not busy. So they take care of the auto scaling, the high availability, and I can deploy directly from GitHub or Azure DevOps or really any Git repo. So that's some pretty cool stuff, right? So they all have various IaaS and PaaS offerings and some SaaS offerings. The newest kind of model that you run into is this concept of function as a service. Not everybody calls it that or calls it SaaS, but mostly you'll hear people talk about serverless compute. AWS probably has the most robust offering for this in their AWS Lambda. And the idea is it's very developer-centric. As a developer, I can build up my zipped-up application, give it to them, and then configure what's the event that triggers that code to fire. And then what I don't worry about is servers, operating systems, high availability, deployment, or anything, right? I basically just say, here's some code, here's what causes it to run. When you upload a file to this cloud storage option, boom, that's an event. What happens? Run this code. And so instead of basically saying, hey, I need to provision a virtual machine and pay by the hour for it, and then have it pull something and find out when an event occurs, I just say, no, run this code when this event occurs, and I don't pay 24/7 for some virtual machine. All I pay for is how long did my code run. So with Lambda, you pay in 100 millisecond increments for how long the function actually runs. And so that really embraces this concept in the cloud of, you don't want to pay for things that are sitting idle. Right? So one way to do that is to build all sorts of auto scaling in that says when we're busy, add more virtual machines in parallel to work, and when we're less busy, get rid of some. The other is to say forget virtual machines altogether and just here's my code, pay while it's running. So it's a very interesting idea. Now, Amazon is not alone. Azure has Azure functions. Google Cloud has Google Cloud functions, and they're all kind of very similar. Those ones came along maybe a little bit later. All right, so let's do a quick rundown of the public cloud providers. We'll go basically in the order of popularity, I guess, starting with AWS. So AWS was established in 2006. They had a couple services that predated that since 2004, but that's when it came out as its own company. That's when EC2 and S3, some of the most popular services, were introduced. And that predates the two biggest competitors, which are Azure and Google Cloud. Those came out in 2010 and 2011, respectively. And so Amazon was able to get quite a bit of a head start, right? And so it's the oldest and most mature platform of the three. And because of that, they gained quite a bit of market share, right? And now Azure has been steadily, growing in their market share. And Google Cloud is really coming along right now, very quickly. So Azure is definitely the second most popular. It's really great if you're a Microsoft shop. So if you're doing, only .NET development and you only use SQL Server for your databases and you don't have a lot of Linux, it's an easy transition if you're a Microsoft shop, Google Cloud, which they used to call Google Cloud Platform, and you still see it sometimes abbreviated GCP. It's very popular with machine learning people, artificial intelligence people, and we'll get into a little bit of why that is coming up. Now, the other two sort of major players, I guess, are IBM Cloud and Oracle Cloud, and they've been around for a little while, but they're a little more niche. They are popular with people who are, say, 100% IBM, and they only want to run IBM stuff in the cloud, that kind of thing. But if we look at sort of how the industry has moved along over the last few years, probably the best way to get that idea is to look at those Gartner Magic Quadrants. So here was the Magic Quadrant from 2017, and if you looked for the 5 years before that, it looked very similar, where AWS was way up here in the top right quadrant as a leader, and then Microsoft every year sort of got up there and closer and closer. And then this was the first year where Google almost got into that box. And then you have IBM and Oracle and a whole bunch of other players. Now, some of those players like Rackspace, early on, they were one of the cloud leaders. But eventually, they were getting beaten so badly by Amazon that they basically went with the, if you can't beat them, join them, right? And basically, they've kind of pivoted. They have some cloud capacity themselves, but mostly they'll be a managed service provider to manage your stuff in AWS. When they went to 2018, Gartner decided to just forget about the other, 13 or however many players and just concentrate on these top ones. And so at that point, Google popped up into the top right box. And the other major player, which we don't talk about too much here, is Alibaba Cloud, because, really it's in China. And the last one that we don't have the 2021 yet, but here's the July 2019, looks very similar. And so AWS continues to be that sort of best in its ability to execute, but now we see that Azure and Google Cloud are approaching in terms of completeness of vision. Right? Now, what does that mean for market share? Well, this doesn't tell you much about market share. So here's a quick thing from Canalys. They do a bit of a kind of survey, and they find out who's using what. And so here was their full year 2019. It looks like about 34.5% of the market is AWS, around 18% Google Cloud, or sorry, Azure, and 6.2% Google Cloud. And notice the others is about 43. And you'll notice that the others is going down. You know, the year before it was 44. And look at the, you know, if you look at the annual growth, the growth here is really in Google Cloud. About 2 years ago is when Google seemed to decide that they want to really tackle this as a business, and they started to put a lot more money into it. I go to the Google Cloud Next every year. This year it's starting today, actually, but it's just a virtual free event for the next 9 weeks or something. There's you know, every week there's a different focus, and there's a bunch of different free kind of on-demand webinars you can watch, but you know, usually it's one of those big, you know, San Francisco conferences, and you know, the last couple of years it's really grown, right? And that gives me some idea of how popular it is. But yeah, Google Cloud is starting to really come on, but AWS has enjoyed a large market share for a long time. All right, so let's talk a little bit about the infrastructure here. So when we talk about AWS, you know, what is there? Obviously, they have a bunch of data centers, right? They're all around the world. But what they do is they usually build not just one data center, but usually it's a cluster of a few right beside each other. And that cluster of data centers they call an availability zone, or sometimes I'll use the abbreviation AZ. That's a very popular abbreviation for it. And the idea is you'll have this cluster of data centers, and then miles away, there'll be another cluster of data centers, right? And 2 or more of these AZs within a few miles of one another, we call that a region, right? And so they have 24 of these regions around the world. So probably the biggest and oldest region, definitely the biggest and oldest region, is in Northern Virginia. Say, you know, just outside of Washington, D.C., sort of near Dulles Airport. You know, they have a cluster of data centers in one town, and then a couple towns over, there's another cluster of data centers. And the idea is that they're close enough together that Amazon can put very low latency, high throughput links. So if I need to, you know, replicate data between these AZs, we can do that pretty quickly. But they're far enough apart that if there's some sort of localized disaster that might take out that cluster of data centers, you know, hopefully it won't affect the other, right? And so anything they can do to make them independently available zones, you know, they'll put them in different floodplains, they'll put them on different sides of fault lines. Ideally, they even put them, attach them to different electricity grids if they can. And of course, they have separate generators and everything else. Anything they can do so that if, you know, something goes wrong here, I've still got that other AZ going, right? And I mentioned they have 24 regions with 76 AZs around the world. And if you want, you can go look at that global infrastructure, you know, the live, you know, they tell you, okay, 24 launch regions plus 3 more coming soon. If you click on this, it'll actually take you to sort of a picture of the globe where you can go and look at, say, here, let's look at North America. You'll see in North America, there's 7 regions. There's 1 in Canada and 6 in the US. Of the 6 in the US, there's sort of 2 special ones. So notice there's GovCloud West and GovCloud East. Those are special ones you can't just use right out of the box. Most of the regions, so 20 out of the 24, as soon as you create an account, so you give them a valid credit card and a valid email address and a password, that's it. That's all you need. You log in and you can start running things in any of these regions except 4 special ones. So these 2 GovCloud ones, you have to fill out a form. They do a background check to make sure you're either a green card holder or a US citizen. They don't want foreign nationals working in there, because what they really try and do is lock down just services that are really vetted by the government for things like ITAR compliance, FedRAMP compliance, and you know. So if you want to do business with the Department of National Defense or something, you have to do it in there. The 2 in China, the 2 regions in China are kind of similar. You have to fill out a form saying how and why are you doing business in China, right? And but otherwise, you know, you can pick your region based usually on, you know, might be data sovereignty laws. So, hey, I need to run this in the US because I can't store this data outside of the US, right? Or possibly, you know, you still have lots of choices. There are, you know, not every service is available in every region. So you might want to pick a region that has the services you need. And then usually it comes down to latency, right? If all your customers are in Japan, well, then you don't want to run your web server in Northern Virginia. You want to run it over in Japan, right? So, so wherever your customers are, or maybe proximity to your own data centers, if you're moving a lot of data back and forth between the cloud and your own data centers. And then finally, there are some price differences. You can imagine running data centers in the middle of nowhere in Oregon is much cheaper than running them right in Palo Alto, right? Real estate, labor, electricity costs, everything's different. So there are some slight variations there. So I talk a lot about the infrastructure here for AWS because it's very similar if you look at the others, right? So if we go to Azure, they also have a concept of regions. They have 50 regions. It's a lot more regions, but their concept of a region isn't necessarily at least 2 AZs where there's a bunch of, a region can be as small as one data center. So Azure was able to jump into a lot more countries quickly because, the barrier for entry of them setting up a region, because it could be just one data center, is much smaller, right? So Azure groups their regions into something called geographies, which usually share, data residency and sovereignty laws and all that. So usually at a country level. And so they have a similar kind of diagram. If you go look at it, it's, scroll down to the diagram, there it is. So same kind of idea, but you'll notice that only some of them have this diamond in it, meaning that they have multiple availability zones. So if you look, like most of the regions don't have multi-AZs. So their terminology is a little bit different. And what you find is that the terminology from Amazon and from Google Cloud are very, very similar. So Google Cloud also has 20 regions made up of 67 zones. Actually, I haven't looked today to see if that's right. I may have needed to update my slide. Let's see. 24 regions with 73 zones. Oh yeah, that's what I thought. All of these providers are adding new infrastructure every day, right? So pretty quickly, as soon as I make one of these slides, it's out of date. Google's very vocal about their vast network infrastructure. Some of the other providers don't talk a lot about their network, but very similar terminology to what AWS does, and similar kind of concept of a region is made up of multiple AZs. And we're going to see that, all these cloud providers, they make it very easy for you to be highly available within one region, right? So when you store some data in cloud storage, it gets copied around to multiple AZs, so that's multiple data centers that are geographically, miles apart, right? So it's very hard for Amazon or Google or whoever to lose your data when it's stored in one of those highly available things at the region level, right? When it comes to launching a single virtual machine, you're generally launching it in one data center. But what you can do is build sort of an auto-scaling group that spans across multiple AZs and say, well, let's not just launch one web server, let's launch 10. And it turns out it's the same price if I launch all 10 in one AZ, or if I launch it into an auto-scaling group spanning across 2 AZs, where I've got 5 servers in this AZ, 5 servers in that AZ. So you're a bit of a sucker if you don't take advantage of the multi-AZ concepts, right? Because what happens is, this auto-scaling group says, hey, I'm supposed to have 10 web servers. If one dies, it'll get replaced. If a whole AZ goes down, I've still got 5 running in the other AZ, and I'll bring up 5 more over there, right? And so it's just more highly available, right? So it's very easy to make these robust applications within one region. Now, if you need to have presence in multiple regions and sharing data between them, that gets a little bit more on your side. There's a bit more work on you to do that. But they do a great job of high availability within one region. So let's talk a little bit about the case for each provider. We'll start with AWS. Well, it's popular because it's popular, right? It's very easy to find people who know AWS. Now, to get experts, to find somebody who's got like a professional certification, you're gonna have to pay a little bit more money, but it's certainly the most abundant as far as the, trying to find architects or anything like that. It seems to have the least amount of downtime of the big three. There's a third-party company that basically shows you what the uptime is for each of them. And in my estimation, they've got the best overall breadth and depth of services. They have over 175 services, and I'd say they have the most mature and popular serverless option, which includes Lambda. Right? So that's a little bit about AWS. Now, it seems like we have a couple questions, so maybe Lee, you can let me know some of those questions.
Yeah, we have one question that comes in. With CloudFront, can we ensure that cached data does not leave the US?
Oh, yeah. So that's a good question. So when I showed that diagram of AWS, in addition to the 24 regions, there's a bunch of little pink dots in major cities all around the world. Those are called edge locations. And the idea is, it might not be a full, collection of data centers that Amazon built. It might be as small as, just one floor of somebody's data center that they secured the heck out of, and they said, okay, this is for use with a small set of services that need proximity to the customer, right? And so a good example would be DNS hosting, right? So if you want, hey, milesbrown.com, I need to, map that to some IP address, right? So I need a network of DNS servers around the world to do that. So I can go to a third-party company to do that, or I can go to Amazon. And so they'll use their edge locations around the world to do that. Another service like that is called CloudFront that needs that proximity to the customer, because what it is a content delivery network, or CDN. And the thinking is, if I've got a website that's popular all around the world, and I'm hosting it in Northern Virginia, somebody from Osaka, Japan tries to come and load my web page, it can take a long time, right? The speed of light matters when you're going all the way around the world. But what are you going to do? Well, what most people do is they go to a third-party company like Akamai, and they say, hey, I'm going to tell you, which things in my website are static. And so the first person in Osaka, Japan that tries to load my web page is going to feel that sting of latency. But subsequent people that come after that, they're going to be able to get the cached version that's in some data centers closer to them. Right? So that's why we need these data centers all around the world. So CloudFront is very, very similar concept. But what we have to do is we have to go and set up a CloudFront distribution and say, hey, anything that ends in .jpeg, anything that ends in .css, maybe JavaScript, we tell them what patterns are my static content, and then these are the things that will cache, so that the first person has to load those from around the world, but then subsequent people from that geographic area are going to get the static stuff. Now, when you set up one of those CloudFront distributions, you can decide, do I want to use all the edge locations around the world, or do I want just the ones in North America, or just the ones in Europe? So you can decide which regions to use. And there's definitely one that says only US only, right? So that static content is only being cached in the US data center. So it's a long way to get to the answer of yes. All right, good question. Lee, any others?
All right, great question as well. We have one more. Is the whole point of cloud that the redundancy is automatic? Is this true? Is this something that you have to build yourself as you set up your virtual environment?
Yeah, that's a good question. Some things have redundancy built in and some don't. So if you look at AWS, one of their major storage options is called S3, Simple Storage Service. And so you come in and at a region level, you set up the top level namespace. It's called a bucket. So I create a bucket, right? And I get basically a URL for that. And then I use HTTP or HTTPS, and I come in and basically with RESTful web service, I can do a get or a put or a delete. Right? And that's how we, put files into that storage. And basically I could do it from anywhere on the internet as long as I have the right permissions. Now, because I create that at a region level, the data actually gets copied around to 3 different facilities, 3 different data centers. At least one is in a different AZ than the others. So that is very highly redundant. And they like to say it's got 11 nines of durability, right? Which means, if you put a file in there today, chances of Amazon losing it in the next year is 0.00001%, right? And so that one has redundancy built in. But if I'm launching a single EC2 instance, I'm launching it into one AZ. That's just a single virtual machine. It's a piece of software that could die anytime. Right now, I've seen these EC2 instances, these virtual machines run for over 3 years straight. I've seen ones die after 3 seconds, right? So there's no guarantee. So we typically say nothing of importance should run on just one EC2 instance. So a lot of times what we're going to do is use that idea of horizontal scalability. We'll say instead of just running one, if it's like a web server or an app server or something we can put behind a load balancer, we say, well, we don't want to launch one, we want to launch 10. And instead of launching all 10 in one data center, we're going to create an auto scaling group that spans across these 2 AZs. So we say, what does one server look like? We make a launch configuration. Then we say, let's make an auto scaling group of 10 of those that spans across. So it's not redundancy built in, but they've got a nice, easy way for me to add that. Right? So it depends on the service, whether or not it's at the region level or at the AZ level, that kind of thing. That's a great question. Is that it for now, Lee?
Yep, that's all it.
All right. So we talked a little bit about why AWS. Like I said, it's the most popular, so a lot of people go to it because of that, right? But I think it really does the best overall job in terms of breadth and depth of services. Azure and Google Cloud are getting very close in terms of the same kind of breadth of services. But if you look at Azure, it tends to be popular because so many organizations already have Office 365, so they've already got a way to pay a monthly bill to Amazon, to Microsoft, right? So it's an easy transition to start using their cloud services. They have a great PaaS offering, so if you are a Microsoft shop and you're doing .NET applications, they're really good at those. They're also very popular with organizations that want to do hybrid cloud, where they have some things in their own data center and some things in the cloud. They have something called Azure Stack. It's basically hardware and software to run the exact same Azure services that you would have in the cloud, but in your own data centers. You can use one pane of glass to kind of manage both the private and the public cloud. Okay. Also, Azure had a presence in a lot of countries before some of the other cloud vendors, mostly because their idea of a region is much smaller. But if you have data sovereignty issues that need you to be in a specific country, I mean, often Azure might be your only option, right? So it is pretty popular with places that are heavy into Microsoft. Doesn't mean they can't do Linux. It's just I don't think that that's what they do best. Google Cloud is growing in its popularity, especially with organizations that are heavily into machine learning and AI. Right? If you think about it, Google built TensorFlow, and they use their own deep expertise of research and development into machine learning, and so they do a really good job of managing that in the cloud. They also created the popular container orchestration framework Kubernetes, so they do a great job of that. They have a service called GKE, Google Kubernetes Engine, and it does a great job of managing basically the control plane for your Kubernetes. Now, doesn't mean that the others don't. There is an Azure Kubernetes service, and AWS has EKS, but Google sort of does a really good job of it. Mm-hmm. They probably have the cheapest pricing, although it's very hard to compare. People have enterprise agreements and volume discounts. I would say they have probably the cheapest pricing maybe for compute, maybe not for storage. I think Amazon S3 is pretty good for storage. Nowadays, they have something called Anthos for hybrid and multi-cloud environments built on top of Kubernetes, but allows you to sort of take these things and you don't care really where the workloads are running in your own data center or in the cloud or even multi-cloud. So they've really, they've really come on. Like I said, just in the last 2 years, Google has made a big commitment, and you can tell by how much money they're throwing into it that they really want to be in this business, and they seem to be doing a good job. But like I said, all of them are sort of so far behind Amazon in terms of popularity and market share that it's hard to overcome that. Right? Now, a quick note about multi-cloud. right? I've used the term multi-cloud and hybrid. It's worth talking a little bit about it. But there was this survey that RightScale did. I think RightScale's name has changed now, but last year they had this survey where they asked people in IT, people who were in sort of larger companies, what's your strategy? Are you using a single public cloud or a single private cloud, no cloud at all, or multi-cloud? Now, their multi-cloud included hybrid as well as true, like, multiple public clouds. But even multiple public clouds was at 17%. And I think it's grown since last year, even by quite a bit. I'm in conversations with people all the time. I teach a lot of AWS classes and I teach some Google Cloud. In these classes, what I find is, people may have started moving to the cloud 5 years ago, and at that point, Amazon was the clear winner, and so they would use AWS, and they moved a lot of infrastructure in there. And now their analytics teams are saying, I like what Google Cloud has. Can we use that just for analytics? And we'll grab the data that's stored in Amazon S3 buckets, and we'll pull it in to Google Cloud just so we can use their superior analytics services. And I'm seeing that all the time. Now, mind you, I'm teaching a lot of the higher level analytics classes, but I see that all the time. And I also see places where they say, you know what, we don't want to get into some place where I'm stuck with one vendor and I'm beholden to them. So I want to make sure that we have talent within our company to deal with AWS and Azure, Now, this idea of hybrid cloud is wildly popular because a lot of big organizations already have a bunch of data centers. And you're not just going to scrap, you went and spent millions of dollars to build data centers around the world. You're not just going to shut them down for no reason. That idea of hybrid cloud where you still have some stuff in your own data centers, but you use some stuff in the cloud, right? And so some people use the public cloud for what we might call cloud bursting, where we're primarily running workloads in our own data centers, where the costs are very much under our control, but we only use public cloud for excess capacity when we're at our busiest. Right? So there's some people that do that. A lot of people, they'll say, well, no, I have certain mission critical apps that have to run in my own data center because I haven't really explored the security implications of moving all those things to the cloud yet. And so we'll use the cloud for non-mission critical stuff, dev and test. That's usually how people start, right? But once they learn the power of the cloud, they learn that certain apps really, can embrace that elasticity in the cloud and work much nicer there, then they'll start putting more and more, any new development will be cloud first, right? And so over time, I think we see most organizations I deal with, they were just dipping their toes in the cloud, using it for off-site backup, for dev and test environment. And then they started relying on it more and more. And at some point, they've got this old data center that needs to get refreshed. And at that point, your CFO says, well, I can spend all this money to go and lease some land, build data centers, all this, fill it with hardware, or I could just pay more of a monthly bill, right? So that trading CapEx for OpEx, even if I wasn't to save money, that's very attractive too, right? Because I can use that capital for something else. But you probably will save money, right? You save money in the cloud because you don't pay for idle resources, right? You don't have to do such a good job of capacity planning, right? Because you can sort of be more reactive. You can bring up infrastructure quickly, and if you don't like it, you can get rid of it, right? So there's some real benefits to going to the cloud. What we're starting to see a lot more of now is this idea of multi-cloud, using multiple public cloud vendors to take advantage of the sweet spots that each one has. And so one of the great examples I said was, hey, we like AWS because it's broadly great, but I'll also use Google Cloud for just the analytics part, right? So we're starting to see that a lot more. And then there's other companies that say, hey, we want to be cloud agnostic. We're going to build an app that can run in any cloud. And that way, if all of a sudden, our relationship sours with this cloud vendor, maybe they're trying to raise prices. They generally don't do that, but whatever goes wrong, I can move my workloads to another cloud. That's not as easy as it might sound, right? Because they all have very similar services, but they're not exactly the same. But if you do want to be cloud agnostic, there are some tools that you can use where you say, well, I'm not going to rely so much on all the little bells and whistles that my cloud provider has. Maybe I'll use some sort of a PaaS framework. So to this end, there's things like OpenShift and Cloud Foundry, even Kubernetes to a certain degree, where you say, my app looks the same, whether it's running on-prem or in one of the public clouds. And so I'm going to build that out and use the services that framework provides. And I won't rely on any other fancy services, and then I can move that to anywhere I want it to. So I won't take advantage of all the bells and whistles of my cloud vendor, but I also won't get that vendor lock-in. Right? So that's something you have to decide where you want to land on that. Now, the problem is, there's a lot to learn. And when you first go in and say, sign up for an AWS account, you're faced with this management console. You first log in and you look at it, and there's over 170 services. I can only imagine today, if I started today and I see this list, I'm like, oh my God, there's a lot there. I have to learn all this? Turns out you don't. But when I learned 10 years ago, there was only 8 things in this list. It was really easy to learn all of AWS at that point. But if you look, there's a lot of really niche things. Look at this one, ground station. The tagline is communicate with satellites. Well, I'm never going to have to do that in my job, I don't think. Right? So I'm never going to learn about ground station other than to know that it's not for me. Right? So there's a lot of really niche services. What you need to learn is what are the dozen or so services that everybody uses. And probably the easiest way to do that is to take some training. Right? And so the Computer Workshop has all kinds of training. We have both in-person and virtual classes on cloud technologies. So AWS, right now we have a lot of virtual training. And so you can go to this link and see all the AWS courses. There's a bit of a sort of an outline. You can see the different sort of paths for classes and certification. And then somewhere in here, view the upcoming classes. And, you can see the dates, where they are, so on and so on. So that link is in there. The other link I have for Azure and really any Microsoft training, we can go and click on that and see what they have for Azure classes. This will take you right to the various Azure classes. And they have a very similar kind of set of classes, whether you're an administrator or an architect or a developer or more DevOps or maybe security focused. There's sort of a path for each of those as well. Typically, there's a 1 or 2 day kind of intro or essentials or foundation, depending what, so here in Azure, it's called Microsoft Azure Fundamentals. There's a 1 and a 2 day version of that, depending how much labs you want. In AWS, it's called AWS Technical Essentials, is usually the good starting point for somebody who's going to take more technical classes and they want to get some hands-on. There's also a Cloud Practitioner Essentials, which is sort of a little higher level, maybe if you're not super technical. If you're interested in Google Cloud or any other training needs, you can either call the number or visit tcworkshop.com. And beyond the public classes where you can just register one person to say, hey, we need a Google Cloud class or something, you call, talk to a rep, and we can set up private engagements. So we got it kind of covered on all those fronts. But the AWS classes are wildly popular. They run all the time, and like I said, there's a good track where you can take a 1 day class, or you can, like in the same week, you could take the technical essentials and then the architecting class, or you could split it into different weeks, maybe. Depends what you want to do. But all 3 vendors have training classes that are authorized classes that map pretty closely to the certification paths. So if you want to get sort of an associate level or a professional level designation, they have those. Typically, the professional ones are a lot more difficult, and you should probably have a couple of years experience under your belt. The associate level ones are usually, hey, if you come and take a 3 or 4 day class, you do some self-study, you should, maybe run through a couple practice tests, you should be able to pass that. And there is some real value to getting those certifications. I remember when I first got my DevOps professional. The professional ones were a whole another level. But the day I put that into my LinkedIn profile, I was getting, headhunters the next day, recruiters coming looking for me, right? Because with the AWS ones, I know that, to become an AWS partner levels, the different levels of partnership, companies like the consultancies and people like that, they need so many people with, associate level and professional and specialty certifications. And so it might be easier to hire somebody who's got a professional certification than to build one internally, because it's, a lot of work to get to the professional ones. So I think that's the main things I wanted to cover. I got 10:44 a.m. So I've got time for some more questions. I don't know, Lee, do you have any loaded up for me?
No questions at the moment. So if anyone has any questions, feel free to put them into the questions box and we'll get them answered for you.
Yeah. All right. I guess we have a recording of this that we'll send out to people. And I think I've got my email in here somewhere. Maybe I didn't remember if I included my email, but we do have the links there to, really just go to tcworkshop.com. That'll be the best place to get in touch with the rep and any questions you have. If you do have sort of bigger questions about technically which class, this one or that one, the rep can bring me in and we can get on a sales call, and I can kind of help out if you need deeper direction technically on what's the right path for courses or anything like that. All right, looks like we're starting to lose some attendees. I don't know, still no questions, right?
Yep, still no questions.
All right, we'll give it a few more minutes in case somebody comes up with some. Just while we're waiting. Oops, where'd that go? So you go to Azure, I showed quickly the, you could set up a free trial. So with Azure and Google Cloud, it's a separate kind of account, a free trial. And they give you so many credits towards Azure products and then a bunch of stuff for free, right? But when you set up one of those free trial accounts with either Azure or Google Cloud, you're not putting your credit card at risk, but there's only so many things you can do, right? But with AWS, you have to put a valid credit card. There's only one kind of account. And if you're careful enough, there's certain things that will be free, but then other things won't be. And so you have to be a little more careful when you set up an AWS account. If you launch something, make sure you turn it off in a reasonable amount of time, because you really have to kind of get used to when you move to the cloud. It's a consumption model. It's like, your water bill, right? You leave the house, you don't leave all the water running, right? Because you're paying for it, right? It's similar. If you're going to launch some virtual machines, when you're done with them, turn them off, right? And you can set alarms to let you know when your bill's going over a certain amount of money, in case you forgot and left something on. You'd rather get an email, after a few hours saying, hey, your bill's gone over $40 or whatever, rather than at the end of the month, you got a $1,000 bill because you just ran a bunch of stuff. But with Azure and Google Cloud, it's a little easier to get in and start that free trial. And it's, truly free, but it's very limited on what you can do. They do give you some free credits towards products that are not free. So that's the idea. But they're all very similar in that they give you this management console, and you're faced with a huge list of services, and it's really trying to figure out, well, what are the services that everybody uses? You know, here in AWS, it's EC2, that's our virtual machines. It's S3, that's one of our types of storage. When it comes to databases, I mentioned RDS. We also have a lot of NoSQL database options. And so one of the things that we find when people move to the cloud is that, you know, they can maybe try some new technology that they, you know, like you might have thought about using MongoDB for some project, but you never knew how it worked. And so, you know, just trying to get together a bunch of Linux boxes to make a cluster, and then you have to figure out how to install it and everything else. Whereas here, you know, with DynamoDB, I just said create a table. And now I got the table, and I can play with it for a while. When I want to get rid of it, I get rid of it. There it is. You know, it's very low cost to experiment. What we find, you know, when we move to the cloud, a lot of times people look at how much money am I going to save? But one of the real things it does is it gives agility to your IT team. You can try things out. If they don't work, you shut them off. Would you pay pennies per hour, right? So when the cost of failure is low, what it really does is it really cultivates this sort of culture of innovation where we can try things and we can quickly pivot our IT. And so to me, that's really the biggest benefit of moving to the cloud. No matter which vendor you go with, they kind of all have that big benefit. All right,
Miles, we have another question that came in.
Sure.
So Red Hat, OpenShift, IBM Cloud, or AWS, what is the future for IBM Cloud given Red Hat acquisition?
Yeah, that's a good question. So basically, IBM had a cloud that was not very popular, and they realized that, you know, being a public cloud hosting company was not what they were good at, and they were losing out market share to Amazon and everybody else. So they said, you know what, let's not. Maybe that's not our business, right? And when they bought Red Hat, it wasn't necessarily for RHEL, for Red Hat Linux. They were really looking at all of the sort of cloud and DevOps ideas, right? So we're talking about OpenShift, which is really a framework built around Kubernetes, and Ansible and some of the other tooling that Red Hat had. And so that seems to be their focus going forward, is we want to be able to build IBM products. They have all kinds of products, and they want to make them really easy to deploy to any cloud. And so OpenShift is really a big part of that, that strategy of being able to build these sort of, now they got them called cloud packs, where they say, hey, I want to buy this software and I want to make it really easy to deploy either on-prem or in any cloud. And so I get this cloud pack that is basically based on OpenShift, which is based on Kubernetes, and it's really easy to deploy, you know, whatever stack of IBM products. And so that seems to be their strategy. Their strategy is multi-cloud or hybrid cloud, but based on OpenShift. That seems to be the strategy going forward. Great question. They spend a lot of money buying Red Hat.
All right, so it looks like we can give it a few more moments, see if we have any more questions that pop up.
I guess just on the website, if you go to topics, and we have to get to the cloud side, I guess. Go to partners, you get AWS and Microsoft that way. Under topics, there was a cloud topic. No, I guess it's under certifications. Oh, here, it's under courses, cloud computing. You'll see they got AWS, Azure, and VMware. VMware is kind of an interesting one. May as well talk a little bit about it. You know, VMware really changed how people run data centers, right? That idea of virtualization, that is the basis for cloud computing, right? That idea that, you know, in the say 20 years ago, if I needed 5 web servers, I would go out and buy 5 physical machines, right? Nowadays, you know, and the chance of all 5 running at a high utilization at any given point is pretty low. But once VMware came out and people started to embrace virtualization in data centers, what we started to see is you would get fewer but bigger servers in your data center, and you'd stack up as many virtual machines as you want. And you could launch them and terminate them, but you were still having to run that data center. And so the next idea is public cloud, where we say, hey, we don't all have to run data centers. Let's just rely on a few companies that are really good at building and scaling and securing data centers. That's really what, you know, Amazon, you know, back in 2004, when they released their first service, people are like, why is this company that sells books making a, you know, an API for doing messaging? You know, it didn't make sense to people. But they saw that market. They said, hey, we're good at selling products online, but what we're really good at is building and securing and scaling data centers around the world. And that's something people will pay for. And so they really kind of changed the game with that. And Microsoft and Google Cloud also really good at building and scaling and securing data centers. So why not rely on them? That's what you're really doing, right? You're renting their expertise in running data centers. And so that's sort of the idea. Now, what if I've already got my own data centers and I'm running VMware? Well, it turns out VMware Cloud is a product where from the same pane of glass, I can decide which workloads do I want to run in my own on-prem, and which ones do I want in AWS or Azure or now Google Cloud, right? And so I can use the same kind of console, the same pane of glass to manage all of these workloads, no matter where they are. So that's another way that people become multi-cloud or hybrid cloud, is using VMware. Okay? And VMware actually has a nice class called VMware Cloud on AWS. It helps if maybe you take like an AWS SysOps or something first, just to get the basics of AWS, but then that class will show you how to run that VMware Cloud using AWS. So that's another class that you might look for, and I think we could probably find that here. Oops. Cloud computing, VMware. Oh, this is by far the most popular class, is the install, configure, manage, ICM class. But yeah, there are some other classes that they have that you can find. All right. Still more questions, Lee, or?
No more questions. If anyone has any remaining ones, but other than that, we could probably wrap up there.
All right. So I'll stop my share. All right. Well, I guess thank you for attending, everybody, and keep your eyes open for the recording that'll get sent to you. And like I said, you know, tcworkshop.com is where you can find all these courses. And if you don't see a course you're you know, specifically that you're looking for, you know, just shoot them a note or call them. The phone number's right there, and I'm sure they can help you, especially if you have any kind of, you know, private engagements or anything else you want to do.